All right, so I want to give you guys a very brief, like you should be able to hold it in your head, idea for exponential functions, which I think you guys already pretty much know. So an exponential function is a function that looks like f of x is a times b raised to the x. Cool? Have you guys dealt with functions like this before?
Yes, we just did.
Yeah, I think we've done a bunch of these. So, for example, you might recall earlier we talked about the function h of x is 2 to the x.
Yeah.
Right? Okay, how would I think about this thing as a times b to the x?
1 times 2
Yeah.
to the x.
Perfect. So you're looking at this and you're thinking a is 1, b is 2, and x is x. Right? The variable of interest is x. You guys good with that? Okay, then we had this other example, which was, what was the other one? You guys remember?
Sum with the h.
Okay, so it was, I'm going to call it g, and it was 2 to the 3x. Right? How do you think about this thing as an a and a b?
1, a is 1, b is 2, and x is 3.
No. So you want to think a is 1. I'm down with that. But what's the thing you're raising to the x?
2 to the 3rd.
It's 2 to the 3rd,
Okay.
so it's 8.
Gotcha.
You guys see that? So it's sometimes useful to write this, because if you can write a function this way, you can kind of look at it and think to yourself, right? A is the initial amount. So that's the starting amount. And B is 1 plus the growth rate. And X is, when you think growth rates, what are you thinking in terms of?
1 plus growth.
Yeah, usually time, right? Yeah, this is 1 plus growth rate. We'll talk about why. You guys cool with this? Do you want to know where this came from? Like why I'm thinking these things? Or do you remember that from Algebra 2?
This didn't seem like.
Yeah, the idea is kind of interest rates and stuff. So let me give you a quick example. So, example, I don't know, let's do pangolins. We love pangolins. Pangolins. I need the 3D printed one to play with right now, but I don't have it. This is a little aardvark looking thing.
This is a penguin.
A pangolin is a little aardvark looking thing.
I like penguins.
No, not penguins. Pangolins. They're very cool.
What about puffins?
They're like a little ant. They're like a little anteater. Anyway, the point is, it doesn't matter. It's some little critter. Okay. So, say we knew that pangolins decline at a rate of 4% per year. It's very sad. Pangolins are going extinct. It's not good. They're very cute. It's very sad. Okay? So, how many pangolins are there?
I don't know.
2,000.
Yeah, I don't know. Let's,
A amount.
okay, perfect. So, there's some amount A of pangolins, right? And then the next year, right? So really I'm thinking here at, right? Time 0, and I've got pangolins, right? So at time 0, there are A pangolins. At time 1 year, how many pangolins are you going to have?
8 times 0.4.
Okay, so they're declining, right, at a rate of 4% per year.
Mhm.
So in a year, there will be 4% fewer of them. So how do you get 4% fewer? A minus 4% of A, right? So I'm thinking here, A minus 0.04A, out of which I can factor A, and so I'll be left with 1 minus 0.04, right? Times A. in the next year, year 2, how many pangolins are there?
Whatever number you had the year before minus 4%.
Good. Whatever you had the year before minus 4%, right?
Yeah.
So whatever I had the year before is this number. And then I'm going to subtract 4% from that. Okay, so I might need it.
P of T1 minus 4%.
Okay, so I have time and pangolins, right? So at time 0, there were A pangolins. At time 1, there was 1 minus 0.04 times A pangolins. Okay, now this one gets ugly. So I need to take this number, 1 minus 0.04 times A pangolins, and subtract 0.04 times this penguin, right? Times 1 minus 0.04 A. Notice out of this thing you can factor a what? Good, you can factor an A and a 1 minus 0.04. You guys see that? So what are you left with there? 1 minus 0.04 A, and then you'd have another 1 minus 0.04 there. Right? That happened at time 2.
What do we do about second .04?
They multiply by each other.
So when I pull this 1 minus 0.04 A out, right? I've got 1 minus 0.04 A times, here there's 1, and then there's a minus 0.04. So I have 2 of these multiplied together, times an A, so I can write that as 1 minus 0.04 squared times A.
Okay, because then I was looking at the third one over.
This one.
So I thought that was your second one.
Yeah, so I'm factoring this out
And having,
of both pieces,
right.
and then I'm left with a 1 and a minus 0.04.
Why isn't it base squared?
Because I'm factoring the A's out. It's multiplied by both pieces, right? Okay, what am I going to have at time 3?
Probably 1 minus 0.4 cubed.
Okay, good. Excellent pattern recognition. So you're going to get 1 minus 0.04 cubed times the amount you started with, right? And so at time t, 1 minus 0.04 to the t times a, right? So that's why I'm starting with these guys, right? I'm thinking A is the starting amount. B is 1 plus the growth rate. The growth rate in this case is negative 0.04, right? You guys see that? So that's where this base comes in. That's the thing I'm raising to more and more powers, right? And then x is really kind of me thinking about time. You guys cool with that? So an exponential function is one you can arrange this way, right? If you cannot arrange it this way, it is not an exponential function. Cool? Check? Questions? Okay, awesome.